Hi, this is 220 and yes, actually, our machine learning model contrastive geochemical self-supervised learning and knowledge distillation for wine quality prediction. Mainly, our model is all about testing and testing the quality of the wine. We have the abstract of our model. This one explains about the quality of wine and how it is influenced, whereby it is influenced by various physical, chemical properties, and accurately predicting wine quality is crucial for winemakers and distributors. Then, basically, quality can be tested in wine industries using different machine learning algorithms as they can analyze complex data patterns and predict wine quality scores with high accuracy. And this one also aims to explore and compare the performance of various machine learning models to predict wine quality based on physical chemical properties. It also explores use of supervised learning techniques such as random forest, support vector machines, logistic regression, decision tree, gradient boosting, neural network, and deep learning modeling to enhance predictive accuracy. Then the objective is to identify the most suitable model for achieving accurate wine quality prediction using the machine learning algorithms. Then for our model, we have keywords. The keywords we have wine quality prediction. We have the random forest, which is one of the machine learning models we have to use. Even support vector machine, even neural network. Then we have model evaluation. We have self-supervised learning, then machine learning. As the keywords considered in our model wine quality. Then we come to the background and an introduction. About the background, back then, the quality of wine was tested using expert wine testers who could assess the wine's color, aroma, flavor, and overall quality, whereby they could first they could hire wine testers to test, and testing it was assessed through the color, the aroma, the flavor of the wine. But then here we have the wine industry relies on experts and sensory evaluations to assess wine quality. However, these methods are subjective, prone to inconsistencies. This means that they used to hire wine testers, whereby that method used to be expensive and it could give inconsistent results of the wine quality. Then, machine learning offers an objective, data-driven approach to predicting wine quality based on measurable chemical properties. The properties we are to consider, we have the pH, alcohol content, acidity, sugar levels, even others. Then, for the recent advancements in artificial intelligence, it has enabled more accurate prediction in various industries. Then, applying machine learning to wine quality prediction can provide more reliable assessments and support decision making in wine production and quality control. All in all, the background and introduction. Back then, they used to hire wine testers, but then now we can test the quality of wine using various machine learning algorithms. Then the technical definitions, we can have we have wine quality, whereby it refers to a subjective assessment of wine based on various sensory attributes like the aroma, taste, and the texture. Then we have the physical chemical properties. These properties refers to the properties we are to use while assessing the quality. And this refers, like some of them, we have acidity, sugar content, alcohol concentration, pH. And then for the machine learning, first the field of data that allows systems to learn from data without explicit programming, enabling them to improve their performance on specific tasks. Yeah, machine learning. Then, when it comes to classification, type of machine learning task, where the goal is to categorize data into predefined classes, such as predicting whether wine is good or bad. So we shall be predicting whether wine is good or bad using a certain range of, can it be 0 to 10? So we shall be predicting that from this range to this, wine is bad. Then from this range to this, wine is good. Then the regression, another machine learning task where the goal is to predict a continuous value, such as estimating the specific quality score of wine. It's like the one I've explained. Good evening. Let me take over from where my colleague stopped. So she stopped on technical definition. The next thing we have is the current trend, like current research trend in the wine industry. And we say that the field of wine quality prediction has witnessed growing interest in leveraging machine learning techniques to automate and improve the process. Like I say that the recent research focuses on, the first thing is the advanced feature engineering. Like this is a technique, like a principal component analysis and feature selection that are being applied to extract maybe relevant information concerning the wine, like to extract those physiochemical properties that are to be used. Then another thing is the assemble methods. This assemble method combines multiple models such as random forest, have linear regression, logistic regression, then also support vector machines like to predict accuracy and robustness compared like to individual models, whereby you're not able to compare the accuracy of different models, then come up with a decision on which one is good or which one is bad or which one is more accurate than the other one. Then the other thing on that is we have deep learning, and we say that the neural networks have been explored for their ability to capture complex relationships and potentially outperform traditional machine learning models in certain scenarios. Like they have that capability of working with different characteristics within those wine sets to predict the quality of a certain wine. Then next on that, we have our problem statement and application domain specific problem of our project is says the traditional approach to wine assessment is based on expert testing panels, which can be subjective, inconsistent, expensive, and sometimes even incorrect, because mainly they based on the tests they feel when they take in the wine. But when you come in with the technical computational problem, this one mainly, you develop an accurate machine learning model that can predict wine quality based on its physiochemical attributes. And this requires selecting appropriate features like handling class imbalances in data, optimizing model performances, and also ensuring generalization like to new data, normalizing the data sets before anything can be performed on it. Then next on that is we have our proposed solution. And our proposed solution is like the purpose of this is to use a supervised machine learning algorithms, such as we have the random forest, the decision trees, the support vector machine, then also the logistic regression. Yeah, because these ones here provide robust and interpretable predictions by combining multiple decision trees. Then for the support vector machine, it's very effective in handling dimensional data and complex decision boundaries. Then when we go to the neural networks that have deep learning models to capture nonlinear relationships in those wine quality factors. Also, feature engineering techniques such as principal component analysis and feature selection like will be employed to improve those model performance. Then we have the hyperparameter tuning and cross validation. That one we use it to optimize the accuracy. Then next on that we have our dataset description. Like this project, we shall use a publicly available wine quality dataset from the UCI machine learning repository. And there are always two datasets. You have the red wine dataset, then the white wine dataset. But for this specific project, we are using the white dataset. And this white dataset, we're using the red dataset. And this consists of red wine samples with 1,599 data points with physiochemical attributes, including acidity levels that one have fixed and volatile, also residual sugars, chlorides, pH, density. As we go on, we shall see that the sample has 1,599 data points and 12 columns that we are going to use. Then also the target variable in this project is the quality, and there we shall use a quality score from 0 to 10. Then we shall use as a classification problem with a quality range of greater than 7 as good, and those ones that are less than 7, we shall treat this as bad or poor quality wine. Then our expected impact or outcome is to improve consistency in wine quality assessment other than using the other traditional model whereby you can't only say that the wine is of good quality by tasting. Then you also reduce reliance on human-based sensory evaluation. I guess it's the same thing. Then another thing is to provide these winemakers with insights to optimize their production process, because they are very sure that after harvesting, smashing, fermenting, everything and keeping in the barrel, they are sure of estimating the quality of their wine using the available models. Then also to enhance consumer trust through more standardized quality rating. Thank you. That's the end of our presentation.